So in this video, we're going to talk about one other way that you can solve systems of equations. So we've talked about graphing, and you find where the graphs intersect. We've talked about using the elimination method to eliminate a variable. And this is another kind of algebraic way that you could solve for x and y in a system of equations. It's called the substitution method. It works very similar to like substitutions in sports. Basically, in sports, you like take a player out, put a player in their place, because usually they're like the same position. That's pretty much what we're going to do here. So for example, if I was going to solve this system, first of all, I actually already have y. Y is -2. Boom, we're halfway there. If I were going to now solve for x, I would need to substitute this -2 in for y, and this is similar to the stuff you've done with the elimination method. I would put the -2 in for y, and then I can solve for x. So in the place of the y that was there, take it out, put in the -2. And so that's going to be +6, because -3 times -2 is +6. Then I'll subtract 6. 4x equals 12, and then divide by 4. And so x equals 3. So my final answer is x is 3 and y is -2. If I were to graph both of these, they would intersect at the point 3, -2, because that's x, that's y. And if I were to substitute in 3 for x and -2 for y, it should give me 18. Let me show you a slightly more complicated example. Not that crazy, but just a little bit more. In this case, we don't have y right off the bat, but I do know that y is equal to all of this. So I'm not able to solve for x and y simultaneously. I can only solve for one variable at a time. So what we're going to do is, basically, since all of this is equivalent to y, I'm just going to take out this y, substitute that in its place, because it literally is equal to y, it is y. So take out the y, put in this, and now my equation will only be x's, and I can solve for x. So do -2x, as it is, minus 3 times y, but in place of y, I'm going to put what y is, which is 6x minus 11. So this was y, but now it's this, and that equals -7. Again, it's called the substitution method because I substituted this expression for y. Now that it's all just x's, I can solve for x. So distribute the -3, so that's -18x plus 33. Still have -2x, and still equals -7. Now I have some like terms. -2x minus 18x is minus 20x. Then subtract 33. So -20x equals -40. Then divide by -20. And so x is 2. Now that's only half the answer. I do need to go back and find y. So just like you did with elimination, go back and use either of these equations and put 2 in for x and see what y is. I think this one's going to be easier because if I put in 2 for x, it'll literally spit out y. So y equals 6x minus 11, but instead of x, put in 2, because that's what it is. So that's 12 minus 11, which is 1. So y is 1, x is 2. You can leave your answer like that or write it like 2, 1. Again, if I were to substitute in 2 for x and 1 for y, both of these equations should be true. Let's try another one. So in this one, it's hard to say what we could substitute in this one. Like in the problem before, I already had y by itself, and so I was able to just substitute that for y. If you're going to use substitution, you have to have a variable by itself, either x or y, but you have to have one of them by itself so that you could substitute in for that variable. So on this problem, I don't have an x or a y by itself anywhere. So I'm going to need to rearrange some things and get one of the variables by itself. That's going to be pretty easy to do with this x. See how I can just like add 2y to both sides? And there we go. X equals 11 plus 2y. So it wasn't too hard to rearrange some things. So now that I know that this is actually just x, I can use my other equation. Don't substitute this into the equation you just used, because this and this are actually the same thing. You need to go use the other equation, and in place of that x, put in this. So it's -7 times 11 plus 2y. Just to clarify, you need parentheses around that because the -7 has to be multiplied by the entire x, which is all of this. Then minus 2y equals -13. And now I've got it all just in terms of y, and so I can solve for y. So distribute the -7. So -7 minus 14y, still a minus 2y. And this combines to be -16y. Then we'll add 77 to both sides. So -16y equals, what is that? 64. And then divide by -16. And so y equals, and you can put that in your calculator, but that's -4. Okay, now that I have y, I need to go back and find x. At this point, you can use this equation, or this equation, and in fact, this one's probably going to be the easiest, because if you just put in -4 for y, it'll spit out x for you. So 11 minus 8 would be 3. Okay, we have one final example. And this is another good one to do with substitution because I've already got x by itself. And so all I have to do is substitute this in for that x, and I'll have it in terms of y. So since all of this equals x, let's plug it in. So 2 times x, but instead of x, put in this, then plus 2y equals 4. And let's see what happens here. So we've got 2 times 2, which is 4, 2 times minus y, which is -2y, plus 2y equals 4. And then -2y and +2y cancel each other out, leaving just 0. And so what I end up with is 4 equals 4. So this is exactly like the elimination problems. If you ever end up with something that is not true, but all the variables are eliminated, something like 0 equals 4, if you ever get something that's not true, that means there's no solution. There's actually nothing that will work to make them true. But in this case, we got down to something that is true. 4 does equal 4, it's just that all my variables are gone. So it turns out these were actually just the same equation. And if you want to try to rearrange them and see if you can get one to equal the other, that might be a fun little challenge. So since this is true, but my variables are gone, that means that there are actually infinite solutions. Turns out they were just the same line. So the entire line are all solutions. Okay. Oh, I do want to say, you can use whatever method you want to use. You can use substitution if you like it better. You can use elimination if you like it better, and you can graph them if they're easy to graph. I would use whatever method makes the most sense. Like in this case, since it's solved for x, it's pretty easy to substitute. If it were like y equals for both of them, they'd be easy to graph. Maybe you want to graph. If everything was lined up, like x's, y's numbers, maybe you would do elimination.